Well, I've been trying to figure out, by doing some research, where exactly in our history did we start to make our models in physics based on just assumptions and theories and not based on the results of an actual experiment. And I found this video where this person's going into the scientists and the experimenters that led up to this person's Bohr. This person's name is Bohr, and he came up with his postulated structure on the atom and was considered one of the founding fathers of quantum mechanics. But in my research, I realized that in videos such as this one, they explain how somebody like this, J.J. Thomson,
J.J. Thomson came up with a theory on the atom, on the structure of the atom. He actually didn't do an actual experiment. He came up with a hypothesis on the structure of the atom.
Would perform an experiment, and then from the results of that experiment, he would come up with an equation or an explanation on what exactly why he got those results.
Yeah, I made a mistake there. This person came up with a theory on the structure of the atom, and another scientist came up with a atom structure idea or theory based on the results of an experiment proving J.J. Thomson's structure of the atom incorrect. So, yeah, I was just a little off on explaining J.J. Thomson's role in classical science.
And I finally realized that right when they get to the founding fathers, quote unquote, of quantum mechanics, and they say that we're going from classical science to quantum physics science or whatever. Going from classical to quantum physics, they went from doing experimenting and getting results from that experiment, then proposing a conclusion or proposing facts on why you get those results. Right when they jump into the quantum mechanics and they put aside classical, they don't have any experiments anymore. It's all just theory.
Indivisible constituents of matter, but rather complex systems formed by positively and negatively charged parts. In 1904, Thomson proposed a model of the atom in which he visualized the atom as being formed
See,
by
look, this person proposed. See, he's proposing a model of the atom, so he's guessing here. He guessed that this is what the structure of the atom looked like. He didn't have an experiment that proved this. So this idea was eventually proven, well, not wrong, but proven incorrect.
Of accounting for the motion of electrons.
So this is what happens when you perform guesswork.
Ultimately caused the death blow to the plum pudding.
See, in the experiment that caused the death of that theory, the experiment and results that gave the actual facts why that model was incorrect is from this experiment.
Was the famous alpha scattering experiment of Geiger and Marsden in 1909, which involved firing a stream of positively charged alpha particles as a thin piece of gold and measuring the angles of deflection. According to Thomson's model, if you fire high-energy alpha particles at a thin gold leaf, then you should find that practically no alpha particles are reflected by the gold. This is because the diffuse positive charge filling Thomson's atom would provide minimal repulsive force and therefore be unable to deflect alpha particles back towards the source. However, when Geiger and Marsden performed the alpha,
So that was the last, actual real experiment trying to study the structure of the atom right there, were those two guys doing the alpha particle scattering experiment with gold
in March
leaf.
1911, Ernest Rutherford proposed a radical new model of the atom in order to account for the experimental results of Geiger and
See,
Marsden.
this person is coming up with a theory based on the experimental results.
According to Rutherford's model, the atom consists of a tiny positively charged nucleus surrounded by even tinier negatively charged electrons, which occupy the vast regions of space around the nucleus. This explained why most alpha particles pass through the gold leaf, since they are simply passing through the vast regions of empty space.
Explaining the results of the experiment.
However, in those rare cases where an alpha particle collides head-on with the gold nucleus, the concentration of positive charge within the nucleus is sufficient to push the alpha particle backwards.
Okay, see, he's explaining the results of an experiment.
The magnetic force of attraction between the positively charged nucleus they're doing to exist in the space surrounding the nucleus. Then what exactly are they doing? They can't just be standing.
So they're saying that the electrons can't be standing still, or else they'll fall into the nucleus, and the electrons can't be following a basic orbit like the Earth does around the Sun, because what was the reason?
He doesn't state a reason,
I
actually.
didn't quite hear the reason why they couldn't be at certain orbits either, but maybe I didn't hear a reason, because there's now we're getting into the part where they're just going to like explain things now and have no experiment with results proving what they're saying is correct.
Still, because the electrostatic force of attraction between the positively charged nucleus and the negatively charged electrons would surely cause the electrons to be pulled into the nucleus, and this would imply that all atoms are inherently unstable and therefore should collapse. The obvious solution to this problem is to propose that the electrons are in fact orbiting the positively charged nucleus, much like the Earth orbits the Sun, and that it's the orbital motion that prevents the electrons from falling into the nucleus, just as the motion of the Earth stops our planet from falling into the Sun. However, the orbiting electron model doesn't work either. To see why, we need to refer to Maxwell's theory.
To see why? He doesn't even say why.
Which had been developed in the second half of the 19th century.
Yeah, Maxwell. I believe Maxwell. He understood what he was doing. He's one of the first geniuses of our history in electromagnetism.
According to electromagnetism, surrounding every charged particle there exists an electric field. And if you change the position of a charged particle, then the field will also change. Now, according to electromagnetic theory, if a charged particle moves in a circular orbit, then the acceleration of the particle will cause a ripple in the surrounding electromagnetic field, corresponding to the emission of electromagnetic radiation.
Okay, see, this is all. I mean, even though I believe Maxwell's ideas and theories, I believe that every charged particle has an electric and magnetic and electric field out there that's expanding into space at the speed of light. And if that charged particle is moving in a very small orbit, then it's going to be sending ripples through those field lines. Since those field lines are already out there, as it spins, it creates ripples in those field lines and they expand outward at the speed of light. That's what Maxwell's theory is saying, that there's these overlapping magnetic and electric fields out there that are getting these ripples from these charged particles orbiting in such tiny distances. See, that I understand and that I believe.
If we apply this to an electron orbiting the nucleus, then we see that as the electron orbits the nucleus, it will radiate energy, and therefore as it loses energy, it will slow down and spiral into the nucleus.
Yeah, see, the fact that he's saying that it accelerates and causes ripples, and then it slows down and falls back into the nucleus or whatever, see, that I don't think is correct. They have not proven at all anywhere that an electron can be accelerated or deaccelerated. I think the only proof that I've ever seen that electrons can be accelerated or deaccelerated is in the Klystron transmitter or amplifier, where the Klystron acts on a electric charged beam of electrons being shot into a detector or cathode shooting electrons at an anode, and in between the cathode and the anode there are resonators, and those resonators, as they make an electric field and then magnetic field, and as they change those charges, they make the electrons deaccelerate in that beam and then form bunches, and then enter the detector in bunches or in packets. And yeah, the Klystron amplifier is the only evidence that I've seen that you can accelerate or deaccelerate electrons. But as for electrons that are in a standard orbit around the nucleus, it's hard for me to believe that they're changing their speeds, because when you touch something that's physically real, it doesn't seem like the speed of the electrons would change in any way, or else you would be able to feel it. Like if you held a stone in your hand, if the speeds of the electrons on the stone were changing their speed, then how could you not sense that by feeling it? But when they're flowing in a straight line or in a beam, they're not bound to any nucleus, so maybe that's why they have the capability of being accelerated or deaccelerated at that point.
And from what I understand, what this person is saying is that the electron, as it orbits and radiates energy, it should slowly fall into the nucleus, and that's why the orbit idea of the atom doesn't work either, because he says that the electron is supposed to be losing energy as it radiates energy, and due to the loss of energy from it radiating energy, it should fall into the nucleus. But the electron's energy remains constant, and it sometimes radiates energy and sometimes it doesn't, but its energy remains constant. And they say that the reason that the energy remains constant is because it accelerates or deaccelerates, and that's when it puts out energy or doesn't put out energy, is the electron changing its speed, which is kind of hard to swallow, because if electrons are changing their speeds in all atoms based on their radiant energy, then there should be some way of sensing that. And I do not believe that temperature is the evidence for that. Like if you feel something that's warm and it slowly cools down, they say that that's the electrons slowing down as an object loses its temperature or cools off. That's their evidence of electrons slowing down, which I don't believe is accurate. I have another theory that explains where the temperature or the radiant energy comes from based on their orbits and friction that the electrons cause on themselves, and not from acceleration or deacceleration. That, I think, is not accurate.
But regardless of the fact, I believe that these particles are orbiting these nuclei at the speed of light, no faster, no slower, and the specific orbit distances is what determines the frequency of whatever particle that you're looking at.
An electromagnetic theory predicts that this would occur in less than a trillionth of a second. So it appears that the electron cannot be standing still, and it cannot be orbiting the nucleus like a planet orbits the sun.
See, I don't understand how he just came to that conclusion by saying that a charged particle creates ripples. The electron couldn't be orbiting it. I don't see where he comes, how he gets to that conclusion.
So what exactly is it doing? The answer to this question would require a union of the old classical ideas of electromagnetism with the newly developed ideas of energy quantization as put forward by Max Planck and Albert Einstein. And it would...
Okay, now right here is, see, this, what he just told about Maxwell's theory, this is Maxwell's theory, and it's very convincing. But from his point forward, everything that this person says that these people propose are all ideas. They're all theory. Not one of them is based on an experimental results proving what they're saying is accurate. Everything that this person says from here on forth is all based on imaginary ideas, not experimental facts or results.
to acquire the remarkable vision of one man, Niels Bohr, who would become one of the founding fathers of quantum mechanics. In 1911, after completing his PhD at the University of Copenhagen, a 25-year-old Niels Bohr joined J.J. Thomson at the Cavendish Laboratory in Cambridge with the hope of working with Thomson on the structure of the atom. However, folklore suggests that J.J. Thomson and Bohr's relationship did not get off to the best of starts when, during their first meeting, Bohr apparently entered Thomson's office with a copy of one of Thomson's books on atomic structure, pointed to a particular section and declared, "This is wrong."
I apologize for how long this video is going to be. It's not even halfway over yet, so this is going to be a fairly long video.
Abandon Cambridge and head for Manchester, where he had been invited by Rutherford himself. Like Einstein and Planck before him, Bohr realised that attempting to resolve the problems of the atom using purely classical physics was probably doomed to failure. Instead, he should take seriously the idea that energy is only ever transferred discretely in chunks, or quanta, rather than in the continuous fashion predicted by classical physics.
See? No experiment. This is all an idea or a theory. He just said energy must be in chunks or quantum and not in classical. But see, they're going from experimenting results and theories on those results to theories that aren't based on any results. And yet we have built our entire scientific foundation from this point in our history all the way up until today on these theories, these quantum mechanic theories. There's no experiment proving that this is what's really going on. This is just this person's, Bohr's, idea. He did not prove this with any experiment.
Furthermore, Einstein's explanation of the photoelectric effect in 1905 had demonstrated that light should be considered a stream of particles called.
The photoelectric effect that Einstein showed is not fully understood. X-rays, when you have an X-ray emitted by some glowing particle and it hits a metallic surface, it causes the resistance in that metal to drop. Therefore, the electric discharge of that metal is allowed to discharge now. Because X-rays, just like when you're emitting a spark gap transmitter, the spark in the transmitter emits radio waves and electromagnetic waves in the X-ray spectrum, causes the resistance in something like a coherer to drop, and therefore close a circuit and make a bell ring. It was the first experiment done by Oliver Lodge, showing that Maxwell's electromagnetic waves do exist. So with a spark gap transmitter, you can do the same thing that the photoelectric effect does. So that spark gap transmitter is putting out radio waves and X-rays, so it causes the resistance of the metal to go down, which causes a circuit to close, and it causes a bell to ring. The photoelectric effect that Einstein showed is the same exact thing. It's causing a capacitor basically to discharge from X-rays being emitted at it.
But I don't think Oliver Lodge ever got a Nobel Prize, though. Einstein did with his stupid little photoelectric experiment, but Oliver Lodge didn't get shit.
Hypothesized that in order for atoms to be stable, there must exist stable configurations of the electrons orbiting the central nucleus.
See, he took a leap of faith and hypothesized.
And that these stable orbits should depend in some as yet unspecified way on Planck's constant.
And yet unspecified way on Planck. So he's saying that I'm taking a leap of faith. I'm going out on a limb here, but I think this is what's going on in the atom, and for some unknown reason or another, it's linked to this guy's Planck's ideas. We have no experiment to prove this, but we're pretty sure that it's linked to Planck's work as well. No experiment, all just theory.
Furthermore, he suggested that the transitions between these stable states would cause the emission of photons of discrete energy. Young, enthusiastic, and unhampered by the limitations of classical physics, Bohr launched into a period of intense productivity, resulting in the publication of 3 papers
Intense
in 1920
productivity.
that would change the landscape of atomic physics forever.
The publication of 3 papers. No experiment. Just written theory.
Bohr's groundbreaking work focused on the simplest atom, hydrogen, and was based on 4 postulates that combined elements of classical and quantum physics. The first was based on Coulomb's law from classical electrodynamics. According to this postulate, the introduced the idea that the angular momentum of the electron is quantized in units of Planck's constant divided by 2 pi.
See, right there, that is a assumption idea. That's an assumption theory. Despite the electron's acceleration, the electrons do not have a continuous radiative energy, so its total energy remains constant. What? Remains constant. Remains constant. So it's not always releasing energy. It's not always not releasing energy, but its energy will always remain constant, huh? So when it's putting out energy, where does the energy come from if the energy is remaining constant? See, this second one, I don't agree with electron acceleration. I don't agree with this energy continuously radiant energy and then it remains constant. That just doesn't make sense because it's saying it's constant and then it's saying it's not constant. It's saying it's not constant, then it's saying it is constant. And right here is just the magnitude of electron quantity. It's like for every single idea that they have in the structure of the atom, they always have to add this quantum word, quantum theory, quantum gravity, quantum this, quantum that. Oh, give me a break. This is all based on theory, and there's not one experiment that proves any of this. If that's what classical means, to having an experiment that has results that proves what you're saying is correct, if that's what classical means, then I agree with the classical scientists that we need to continue to go down that road. Just coming up with ideas and theories and saying that everybody has to evolve from classical to quantum or go from experiment to no experiment, just theory, and don't you dare question our theory.
Yeah, I love how they just stick by all these theories and they don't even question it whatsoever, and there's not one experiment that proves anything in quantum mechanics. It's all speculation. That fourth one I agree with.
So we will now consider these ideas in a bit more detail. We will begin by looking at the quantization angle.
Okay, this is where they change. This is where they're changing classical physics to quantum mechanics. Where they go from, they take classical equations that were proven by experimental results, and then they take one of those equations and manipulate it into a quantized equation. They're basically taking their the classical mathematics and rearranging them to the point where where it benefits them or their ideas.
We see from this expression that according to classical physics, because the radius and velocity can vary continuously and take any value, so too can the angular momentum. However, Bohr proposed that the angular momentum of the orbiting electron is quantized in integer multiples of Planck's constant divided by 2 pi.
Okay, right there. They go for this they could have stuck with and experimentally proved this correct, but right there where they jump from a possible experiment and results to prove fact, they jump into this equation, which is just theory. This equation was not proven by an experiment. This is where they go from classical to quantized, or from experimental results to no experimental results and only theory.
If we combine the classical and quantum expressions for the angular momentum and rearrange for the radius of the electron orbit, we find the following expression.
See? And that's what they do from here on out. They combined that equation with some equation that they got out of their ass to make some new equation that is not valid according to classical science, and that leads them to a new equation that is not valid, because everything that is based on an invalid equation to begin with is all invalid from there on forth. Like, every single thing you get from an invalid equation is also going to be invalid. You don't go from an invalid equation to a correct equation. So right here is where they made their mistake. This is them manipulating the mathematics of classical and their new quantum mathematics together to make an equation that isn't proven by experimental results. So that makes everything from here on forth not valid. It's like they didn't know where to go once they got to this L equals MEVR equation. They, I guess, got lazy and didn't want to keep experimenting with angular momentum at that point forward. So
Yeah, see, they could have taken the classical angular momentum equation and did experiments with electromagnetic wave frequencies to try to determine the orbits of electrons and their angular momentum with those classical equations. But as soon as they go into this quantum equation and add nh and 2 pi, which is not part of the angular momentum equation, then it leads them to these equations here that are not valid, because they're not proven to be correct. Like, I could come up with an equation out of my ass and put numbers into it and say, look, this equation says these numbers equal to this, and these numbers, if I plug them into another equation that I pull out of my ass, they'll equal to this. So this is what's going on. See, that's what they're doing. They took a classical proven angular momentum equation, added in an equation that wasn't proven, combined them to benefit their ideas, Bohr's ideas, and come up with a new invalid equation. And from here on out, it's all invalid quantum mechanical explanations. This is all pseudoscience. This is not real science. This is all speculation. So this is where I'm going to end the video here, because this is from here on out in this video they come up with equation after equation, or he says we get the following expression, and then we get it there, here, then we get this new following expression. So every single expression or equation that this person proposes after this point is not valid, because they take an equation that was proven right with an equation they got out of their ass, combined the two equations into a new equation that they get out of their ass, and then they come out with another equation that they get from an even deeper point from inside their ass. So this is why quantum mechanics is wrong. This is why anything that theorizes in quantum theory is inaccurate, is not correct, because they take the mathematical equations, manipulate them around to suit their ideas, and that's not how you perform science. You take an experiment, results from that experiment, and that's what you base your mathematical equations on, not from taking an equation that you got from nowhere and manipulating the numbers around to suit your ideas. That's called manipulation of science for deception. And in my opinion, all these quantum theory, quantum mechanical ideas are all based on incorrect equations and therefore are invalid science.